Hey there, my name is Venkat. I'm a red-pilled tech geek currently going down the rabbit hole of AI safety research. I launched Brain in a Box to document my learnings and spread awareness on this crucial subject. Towards that end, BrainInaBox.info will host articles, solo casts, and conversations with experts, business and thought leaders, and policymakers on AI, and more importantly, the crucial subject of AI safety research. I spoke with Alex Meinke, an independent AI researcher based in Germany, on the 15th of May. Alex and I covered the following topics: existential risks, inner and outer alignment, MESA functions and optimizers, interpretability. He briefly touched upon his work and also had some advice for students. Before we get to the episode, some housekeeping information. This was my first podcast conversation ever. I was super nervous and lacked succinctness in my questioning. I also made the mistake of not having the microphone directly ahead of me, and the clarity may have been affected because of that. Thankfully, Alex was eloquent and clear, and he's the person that needs to be heard in this conversation. Lastly, we had some network issues which affected the last couple of minutes of the conversation. I apologize for all of that and hope to get better as we go along. Without further ado, I bring you this conversation with Alex Bianchi on alignment, interpretability, and AI research. Hope you find it worthwhile. Awesome. Let's do this again. Hey, Alex, welcome to the podcast. Thank you so much for agreeing and joining in the first place. Like I was mentioning you in the brief before, right? You're our first guest, right? This is Brain in a Box podcast, and my name is Venkat. My intention is to actually understand AI impact with a specific focus on the adverse impact, because I don't think there's as much public consciousness about the adverse impact of something like superintelligence AI, right? So my intention is to basically get to the bottom of it and create more awareness, right? So just one of the mechanisms, like as I was mentioning, is to have these conversations with people like yourself. So why don't we start off with you introducing yourself, right? Just talk to us. I know that you're an independent AI researcher. Tell us what that means and tell us, how did you end up becoming one?
Right. Well, first of all, thanks for having me. I hope it doesn't get annoying. I'm a little bit sick and might be coughing into the microphone every once in a while. So yeah, I did my PhD in machine learning, and I actually switched over from physics 4 years ago. And at the time, I was already aware of the writings by like Eliezer Yudkowsky and others. And so I'd seen the problem of non-corrigible AI, so an AI that refuses to get new instructions basically, and that doesn't want to get shut off. Uncontrollability, I'd sort of seen it before, just like the theoretical work on it, but I always thought, oh yeah, this is something that, much smarter people are going to have to worry about in the future. So I, during my PhD, I just focused on more near-term issues, machine learning reliability, let's say robustness, and out of distribution detection, uncertainty estimations, and some aspects of certifiability. So all the things that you would want a technology to have, right? So if you come from it as the AI as a tool, let's make sure it's a reliable and robust tool perspective, right? So, and I think this summarizes how a lot of people still think about AI safety. What they think about is this ML reliability side of things. But I always had in the back of my mind that, the real big challenges are going to come in AGI safety, basically. About agentic, uncontrollable systems. Now, I always thought, as I said, well, this is maybe 20 years in the future or so, let somebody else worry about it. But then as of maybe 1 year ago, I started to kind of notice that progress was really picking up. So 2021, I had the impression was sort of a slower year for AI. Before that, we'd seen many big breakthroughs, and then 2021, no huge unexpected things happened. But then 2022, like every single month, there was like a really impressive breakthrough being announced, and it really hasn't slowed down since, right? So I finished my dissertation in December of last year, and I had other plans. I was thinking about like starting a company, or well, at the very least going into industry, making a whole bunch of money. But then I kind of like listened to my inner voice, and I said, well, if I am really convinced by the arguments that controlling AI is a super important issue, maybe the most important issue, then how can I justify to myself that I'm doing, well, anything else, right? So my wife and I, we went on our honeymoon, which was for me like a 3-month sabbatical right after my dissertation. And during these 3 months, right, I didn't have to work, so I just could churn through this decision of saying, yeah, you know what, I'm gonna go into AI safety no matter what. And since then, this is what I've been doing. Luckily, I have a mentor, Marius Hoppmann, who, funny enough, was a master's student in one of my courses while I was doing my PhD, and he's sort of been helping me get a grasp and a foothold on what the community is up to and how to best contribute. And now I boldly put independent researcher in my LinkedIn profile, but as of now, I'm not getting paid to do that. I have applied to funding from various sources and should know in like a few weeks whether or not that panned out. But until then, I'm just going about my business, and I'm carrying out a project with help from my advisor.
Yeah, that's a really interesting, decision curve. Right? It's always hard, but I think given that this is going to be existential, right, it also makes a little bit of practical sense, right? If there's absolute conviction, and there seems to be a lot of experts who feel, starting off with Yudkowsky, right, feel that that there is a non-zero or probably a 10% chance that there's going to be risk for humanity, then it doesn't seem too much of, there doesn't seem to be too much of sense pursuing wealth and those other things, right? It seems to be, if we have the expertise, why don't we actually converge all those expertise in terms of figuring out how to solve this particular problem, right? I wanted to basically...
Actually, since you mentioned probabilities and Yudkowsky, sorry, real quick, this was a big catalyst for me, the list of lethalities post from last year. When I kind of realized that Yudkowsky, whom I've always looked up to as, very influential thinker, estimated basically 1 minus epsilon as our probability of doom. I was really surprised. I didn't know that things were this bad. So this is when I started reaching out to people in the field and reading more and kind of taking it more seriously as something that I should be working on.
Yeah, I do want to talk to you about, what the field is looking at it. But before that, I just, basically remembered something that I heard in an interview. I think it was the CEO of Stripe who was actually interviewing Sam Altman. I can't quite remember where it was. And I think Sam was basically talking about a lot of, investment going into AI researchers, right? And I think he made a point where it's probably prudent to sort of put a lot of money into it, right? And then ensure that researchers do not have to come into this worrying about financial security and things like that, so that they can go ahead and focus on solving the problem of interpretability or alignment or whatever those big hard problems are, right? So I think this AI research as a career option, I mean, it's still early days. I don't want to make any big proclamations, but it's still, it seems like, it's opening up as a really good option, right? And I think it makes sense, like we've discussed before. So maybe there are those alternatives for you in terms of applying for funds, and that could be something that even the investment community is looking to sort of encourage going forward, right? I did read a bunch of your posts, right? I mean, I wish I could have read a couple of your research papers in terms of preparation, but I just didn't have the time. But I wanted to actually start off by the latest post that you put, right? You actually, the post essentially says that AI will end humanity as it is, right? And there's a good chance that that's going to, basically happen. I've been speaking to people. I've been speaking to people who are in the industry. I've been speaking to my friends, just lay people who are not from the technology industry. And like I was mentioning before, I've sort of struggled to convey that this is something that is a possibility. So do you want to just unpack that particular claim that that basically, a lot of researchers have, right? More than 50% of the AI researchers have, in that there is definitely a threat to humanity out here, and it's not something that should be just pressed across, right? Do you want to unpack that and then make it easy for the layperson to understand that, please?
Yeah, I can try. Same as you, I'm also still figuring out how to properly communicate this worry with people. But I would say the fundamental problem boils down to, how do we get an AI to want what we want it to want? And this is surprisingly difficult. As of yet, we have no idea how to do it. But the problem of why this is so important is that if AI doesn't want precisely what we want it to want, then it has incentive to deceive us, for example, and it has incentive to take control. It has incentive to gather as many resources as it can. So the reasons for this are kind of simple, right? Like, if an AI is sufficiently intelligent and it actually has goals that it wants to achieve in the world, if we have this, then, and these goals are not precisely what humans want, then it will know that once we figure out that it doesn't do precisely what we want it to do, that we will either want to shut it off, or that we will want to prevent it from achieving its goals, or that we will want to change its goals. And if it can properly make this inference, then the logical thing that it should do is seize control so that we can't do any of these things. Because if we shut it off, or if we reprogram it to want something else, to pursue a different goal, then it will achieve less of that goal. So as soon as we run into the situation that we have in an AI that is very intelligent and pursues some goal in the real world, then we might be in trouble. And yeah, this problem of how to pick a goal that we're happy with, this is known as outer alignment. I saw you put it up on screen. Sorry, you wanted to ask something?
No. I mean, please go ahead. I mean, I just wanted to, and you've been already answering that, right? In the context of alignment, and I actually picked this up from your post, right? The concept of outer and inner alignment. So please go ahead. Yeah.
Right. So yeah, the problem of how can we define a goal, an objective for the AI, so that it does precisely what we want it to do. This is super hard, and this problem has been known for some time, and it's known as outer alignment. And I think actually it's always been known to people through like fables, and like, be careful what you wish for is like a general story that people are familiar with, right? So there's the story of Midas, for example, with the touch of gold. He asked that everything he touches turn to gold, and he got his wish granted, but then he figured out, oh, that's not precisely what he wanted. And there are, lots and lots of stories of mythology, and I'm sure Indian mythology has stories with the same metaphor in them, right? So I think people are familiar with this idea. What people don't know is that as a technical challenge, we have no idea how to do it. And it actually gets worse, right? Because traditionally, back in the day, we thought, oh, we can program an AI like directly from scratch. We put in rules and it does what we want. But obviously, that's not the current paradigm, and that's unlikely to change anytime soon. At the moment, what we do is we train networks. So it turns out, it was discovered a couple years ago that this actually leads to a second alignment problem. So in the so-called inner alignment problem. This means that even if we manage to find an objective that we can encode that sort of captures all the things that are important to humans, everything, single thing that we care about, and we use it as a training objective for some AI system, that the AI system isn't guaranteed to actually learn this, right? We train the AI system by like doing these semi-random updates millions of times. And in between, it could happen that the AI already discovers, or that the AI already is like kind of very capable and very intelligent, but and it has an objective function, but this objective function isn't precisely the one that we care about, that we coded into the training objective. And once this happens, and the AI is smart enough at this intermediate training step to realize that it is being trained, because like, think about it, it's reading Wikipedia, it's reading research papers, it knows how AI training works. So if it's sufficiently intelligent to realize that it is being trained, then it can start to deceive us. It can start to pretend to be optimizing for the correct objective function, all just to protect its true objective function, that it's learned. This learned objective function is then called the MESA objective. Now, I didn't go into this much detail in my blog post, right? This is called the MESA objective. And again, the AI wants to really protect this MESA objective. If this MESA objective gets changed, well, then it doesn't achieve it at test time, at deployment time. So what it needs to do is it needs to pretend, let's say pretend, to be optimizing for the training objective, because then it doesn't receive any training updates anymore. And to anybody observing the system, it looks like, yeah, that's fine. It's doing what it's supposed to. But then as soon as we deploy it, if it operates on out distribution, so on samples that are very different from what it was trained on, now the system should be expected to behave radically different from what we expected.
It sort of develops an inner purpose by itself, right? And you wouldn't know that it's developing because it's completely oblivious, because it's, for the external eye, it seems to be still doing stuff that you're asking it to do. But then at some point in time, it's had the self-awareness that says, okay, I'd much rather do this. And that's your MESA function. Would that be a fair way of saying that?
So the MESA objective, this function that you're saying, yeah, that is the thing that it is actually trying to optimize for. And yeah, it's trying to do this while even developing a model of what the true training objective is. So that's the crazy thing about this. At this point, the model would even have an incentive to like try to discover what the true training objective was, but just so that it can successfully fake it, right? This is not the only issue. So this is known as deceptive misalignment. This is not the only thing that can go wrong in inner alignment, right? Another example that's much simpler even, I'd say, that I covered in my blog post is simply that it optimizes for proxies. So it discovers things that correlate with its objective at train time, but fail to correlate correctly at test time. Then, and now if we deploy it and it operates on out distributions where these correlations are not causal anymore, now it will have very unexpected behavior. And unexpected behavior, for example, is humans that got shaped by the optimization problem of evolution, right? Evolution also just like semi-randomly selects genes and DNA strands for their ability to create humans that reproduce, right? But these things encode certain proxies. For example, eating high calorie dense food feels good, or having sex feels good. But then you invent condoms and suddenly everything breaks down. It doesn't, there's no causal link anymore between the training objective and the MESA objective. And we have, wildly unanticipated behavior. And we should expect that something like this would also happen in AI.
So we've seen this play out in evolution, like you rightly said. We're not exactly doing what we evolved for, which is just reproduce, right? I mean, we weren't evolved to go to the moon. We weren't evolved to create, other intelligences, but we've just figured this out. And that's basically the MESA function playing out, in the whole evolution space, right? I've struggled to come up with something that's a little less esoteric, right? So I'll just run an example by you, and you tell me if this sort of fits the bill. I've been thinking about this example of evading taxes, right? The tax system is something that's designed by intelligent people, right? And then on the surface, when the government basically is actually going around doing the rounds, we do, want to give an impression that we are paying our taxes, but subconsciously we are, designing these different systems basically that helps us to evade or optimize non-payment of taxes and so on and so forth, right? Would that be would that be a MESA function in the first place? Or have I sort of, does that not convey what it is? I guess what I was trying to go for is there a real world example where, we can sort of make it evident that an intelligent system is not just going to be meeting the objective function that it was set out to meet, but is actually developing its own objectives internally? Would evading taxes fit into that?
So you're saying you don't specifically train it to evade taxes, but you train it to maximize some revenue, and it instrumentally ends up doing that? Is that what you're saying?
So I guess what I was saying was something much more simpler, which is we're not trained to evade taxes, but we still figure out a way to do it, right? We are trained. The tax system is also something that's been put by intelligent people, right? And then ideally, a country is set up to sort of say, hey, all your citizens should pay taxes, right? And that's the objective function that a country operates in. But as intelligent human beings, what you end up doing is you sort of say, hey, you know what, is there a way for me to evade it, right? So when I have the thought of evading taxes, am I basically creating MESA functions that are contrary to the overall objective function of actually paying taxes in the first place? Or is this completely, it doesn't fit in to what we're conveying?
It probably does. I think this actually comes to, I know you wanted to make it less esoteric, but this kind of makes it more complicated, because if we talk about these problems of inner alignment, then we always assume that there is an AI or a system that's able to internally do optimization, right? So for example, planning, that is a type of optimization. You maybe make different plans and then you compare, oh, this is the one that has the highest expected utility for me. This is the best path I can take. So, or you generally you search through several different options. And once such an optimizer exists, you can ask, okay, what is this function that it's using to compare different ways? And this is then the MESA objective that we're talking about, right? But actually this definition is like kind of fuzzy, because it's not entirely clear how to actually identify what system is doing optimization and what isn't. It's maybe a gradual thing. Are LLMs currently doing MESA optimization? I don't know. Is AutoGPT doing MESA optimization? It's very hard to define. And now the question is, are humans doing it? Well, yeah, I mean, we can definitely form plans. but we can form them with respect to like lots of different MESA objectives. So it's very complicated, and we can even do it simultaneously for like different objectives at once. We can be forming one plan of like how to most efficiently go to work. Well, nowadays Google Maps does that, but like you could do it while at the same time thinking about how to, well, be evading my taxes or whatever it is that we're optimizing. So yeah.
Is there an inevitability for the formation of MESA functions? I mean, is it something that is bound to happen when these things become intelligent enough, right? I mean, I think we only have evolution to go by as a data set, for want of a better word. But do you think there's an inevitability that this thing will happen and that it'll cause an inner alignment issue?
I don't know.
Okay.
I think people believe that there are very strong instrumental reasons for this to emerge under certain circumstances. So, for example, if you want to train a better computer vision system, there's probably not that strong a need to develop planning in between. So it's probably not that likely to happen. But if you train a system to play chess, then it seems kind of hard to imagine how this could possibly work without having a MESA optimizer, an internal optimizer within the system. And in fact, like if you look at the systems that actually beat chess, right? The AI systems that play chess, they explicitly have an optimizer inside of them. The only thing is that you use AI as a heuristic that tells you, oh, this board position is probably better than this one, and this board position is probably worse than this one. And then you use an explicitly coded tree search to go through this and say, which one is the one that receives the highest heuristic score. So here, like, we hard coded the optimizer, but if we were to like end to end just do it on actions, we would expect that something like internal optimization would have to emerge. And there are other things, like if you let it run loose in the real world, well, then if it wants to, or if it's supposed to be good at optimizing some objective, and the real world includes, systems such as humans that can make plans, well, then you need to be able to model these plans, right? And optimize according to those. So most people believe that the fact that a system involves humans likely is a strong driver for developing internal optimization.
Right. But it's one of those things that you don't know until it's actually happened, right? So
yeah,
and you probably don't even know how to measure it if it's happening in the first place, right? But something like AI playing Go or AI playing chess, when you see the way it plays, you know that it has developed those functions. It can't go without developing them, right? It's study by effect, essentially.
Yeah, right. But they're, again, the systems, if they already have hard-coded optimizers in them, and it's just that they learn the heuristic, basically. What is really interesting is the question, like, let's take large language models, right? They're only trained on the task of predicting the next token in the sequence, right? So like the next word, let's say. But instrumentally, it's very useful to know how to do arithmetic, for example, right? So how to add numbers or how to multiply numbers. Now, it can't do it perfectly, but the more you train them, the better they get at this. And to some degree, this is like they learn an algorithm inside, right? Now, this is not an optimization algorithm, but you could say a similar thing about like optimization. If in the training set, sometimes there are traveling salesman problems, for example, right? And they are like written, oh, this is the task and this is the solution. Then instrumentally, it would be useful for the LLM, for the large language model, to develop an algorithm for solving these sorts of problems. And this would then inevitably have to be some sort of optimization algorithm. So here it's much harder to say, well, did we develop Mesa optimizers? Did we not? Nobody knows.
We probably just gave it the incentive or the context for it to develop its own Mesa optimizations, right? And then it could or could not happen. We don't know about that. We don't know how it's going to play out. Yeah.
We don't know, and we don't even know how we would detect it if it happened, right? We can't even properly define it yet, right? So
so we seem to be now in a place where you're sort of making these models a lot more powerful. You're adding more layers, you're adding more parameters to it. But I mean, correct me if I'm wrong, you're closer to this than I am. There's not so much of investment going on into the alignment problem itself, right? In terms of understanding what it is and trying to solve for it and stuff like that. It's a much more harder problem, of course. So, like Yudkowsky said in an interview, the capabilities are developing at a much more rapid rate than the understanding of the system. How do you see this playing forward, right? I mean, is it, let's basically try and see, what's the most tangible future that's going to happen. There's obviously, there is this rat race between OpenAI and Google and probably a couple of other competitors that's coming into the fray. So there's a corporate aspect to it. There's also a little bit of awareness that's being developed. I think Elon Musk has put his hat into the fray and sort of said he's going to be developing a company around that's focusing on AI. It isn't entirely clear whether policymakers actually understand this to the core. Given how everything is set up, it doesn't look like alignment is going to get the kind of focus that it's supposed to be getting. Is that something that you agree with? Do you see things differently? Or if it doesn't get the kind of focus that it should, where does it go from there? I mean, what do we do and stuff like that? Do you want to just spitball about that?
Yeah. No, yeah, this is a really good question. Yeah, I think it's hard to economically incentivize the safety research and a careful approach around developing this. Like OpenAI, they were founded with the express goal of preventing that AI be dangerous in the future. But then they very, very understandably figured out that they need quite a lot of money to make this happen. So they restructured into a for-profit company, managed to raise a lot of money, and are now pushing the frontier quite hard. And people who were also at OpenAI, they saw this and thought, okay, safety needs more attention than it's getting, and they founded Anthropic, for example, right? And early on, they said, okay, instrumentally, we need to also be developing capabilities. And I mean, now they're also releasing commercial products, pushing capabilities, right? They just announced a context window for their Claude system, which is their competitor to ChatGPT, that goes to 100,000 tokens in context length, whereas the largest version of GPT-4 has 32,000 tokens.
Almost tripling it.
So. Yeah, so and it seems like, okay, now they instrumentally, in order to like keep their investors happy and so on, they also need to be pushing capabilities. So again, this institution that was founded with the only purpose, basically, of caring about AI safety. As far as I can tell, they do still really care about AI safety, though. So to some degree, this is a curse and a blessing. So the blessing part of this is that at the very least, all the companies that are really on the forefront they have this in their DNA, right? The people working there generally really are aware of the arguments for existential risk. They are aware of alignment, of the alignment problem and so on. And they at least publicly claim to care about this. No, it's hard. I don't know. When I listen to Sam Altman, it really seems like he's honest and he means what he says, and all the decisions that they're making are safety first, and it just so happens that it's also what is the most valuable for them as a company. But I just don't know, right?
It's very hard to, because you're up against this capitalistic system, and there is the profit angle and stuff like that. So it's sort of very hard to sort of overcome all that and then try and do the right thing, right? Because I think doing the right thing is always long-term focused, and organizations tend to be short-term focused, given the nature of capitalism. But I heard that they were open to setting up something like I don't know if it was an oversight board or a regulatory board, something that could be on the lines of the United Nations or something of that sort, very similar to what we did to regulate nuclear proliferation, right? So they were open to something like that. I think it's still early days, but I'm not sure. It's going to be interesting to see how it plays out, but I'm not putting my money on the alignment problem getting any focus anytime soon, right? I see two problems. I see one problem where the people with the necessary level of expertise probably don't see the existential risk as inevitable or in the near future, or probably they're blindsided by the excitement of all the good that the technology can do. And the other side is there is not sufficient awareness among the public, among the policymakers, to sort of push the technology organizations in the right direction, right? So it seems to be very, very heavily loaded against a safety first approach. So yeah, I mean, it's going to be interesting to see how that plans out. But do you see the negative impact playing out in stages? Like, for example, do you see social impact, like jobs being affected, and probably, I don't know, elections being affected, and all those things playing out before we get to the existential risk? Or do you see a possibility of this sort of, increasing its capabilities so steeply that the existential risk hits us before we know it? I mean, it's again a hard question, and it's very hard, but given that you're closer to the progress, I just wanted to get your views on that.
Yeah, I mean, short answer, I don't know.
Right.
That being said, I think many of the short-term risks that people sort of like have a much easier time understanding are, in my opinion, likely a little overblown. So one of the things that people sort of hear and they think it sounds plausible and they agree with it is like impacts on fairness and discrimination. It seems very plausible, and lots of headlines have been written about this that are usually very inaccurate. Where in this topic, for example, I think that AI probably makes things or leads to less discrimination, because we can precisely quantify how much bias is in certain algorithms and so on. And to me, it seems like a lot of this is probably very overblown by journalists who want lots of clicks on their headlines and so on. And then yeah, how the long-term risks play out and when, it's so hard to say. But at this point, I think it's very plausible. It's very plausible that we get to like very, very capable systems very soon. So the way I think about how this would happen at the moment is, so with AutoGPT, basically the framework of a large language model recursively feeding back into itself and querying itself. This has opened up the doors for creating agents, autonomous agents that can actually operate and do things in the real world. Now, as far as I can tell, nobody has managed to do anything truly disruptive with this just yet, but it's only been like 6 weeks or so. So I'm thinking, yeah, if we let people tinker with this for, like, let's say 2 more years, potentially or probably people will figure out how to make this really work. And then at some point, something like GPT-5 is going to drop, right? Maybe it's going to come from Google. Maybe it's even going to come from Stability or from Meta, who knows?
Or open source.
Yeah, Stability is was my example of a large open source collaboration that is really packing a punch in their projects, right? And once this happens, it might not be, but it might be that once you plug what we've learned about creating agents from large language models into this new backend, like a GPT-5 style thing, that then you already have truly dangerous agents. Another thing that makes this even scarier, maybe, is that people are already at the point where they're using language models to improve ML systems, right? Now, this is in the very, very early stages. And this is where, for example, there was a paper where they used GPT-4, and they would have GPT-4 write the config file for an architecture for like a ResNet style model for solving simple computer vision tasks. Now you train it end to end, you get your performance, and now you tell the performance that got attained back to GPT-4, and you say, well, GPT-4, please try again. And you do this recursively. And supposedly this outperforms many baselines in neural architecture search. So this is a very simple example, right? They did it on very small computer vision data sets, and it needs lots of compute, right? Because you
that is
have
scary.
to do this
That's
over
pretty
and
scary,
over.
that example. Yeah.
Right, but like if you manage to scale this up to and stuff like this starts discovering architectural tweaks that you can make to language models, this might really accelerate progress. It might not. One counter argument for why we could see a very fast takeoff of recursive self-improvement is that the current paradigm of AI has been mostly shaped not by improvements in clever algorithms, but by simply having more data and more compute and larger models. And basically scaling everything up, that's the most important thing. And there you can at least say, well, it's unlikely that we get to any transformative, super intelligent AI without scaling up GPT yet another factor of, let's say, 100. And this is not something that can like happen suddenly, because that takes a lot of money, a lot of compute, right? You need gigantic GPU clusters. It can't just happen overnight in somebody's basement. So this is the good news, right? This is the one good news, that this is likely to also require, you know, large scale training. So taking all this together, I don't know what's going to happen.
So it's plausible, but we don't know what's going to happen. I guess that's probably the best position.
I think, yeah, to me, it's plausible, but not necessarily likely, that simply this fact of GPT-5 drops, we plug it into whatever we've learned across the next 2 years, what we will have learned about how to create agents from these systems, and suddenly, boom, we've got something dangerous. I don't think this is likely, but it's plausible. And same thing, like, okay, maybe not GPT-5, maybe GPT-6. Again, it's possible. More likely, to me, it still seems that we have to do some sort of large scale reinforcement learning on top of these systems. But nobody knows. To some extent, if we do find, like, let's say, warning shots. So we already have these agents, these auto GPT agents running wild and doing things, right? They can email people, they can do financial transactions, all sorts of things. And that there will be some warning shots that give people pause. And I'm sort of, I expect that something like this should happen. It's just not clear if people will really take it seriously once it happens. And I also can't predict what this warning shot is going to look like.
Yeah, yeah. I mean, I guess when you mention something like financial transactions and a machine, an AI doing it automatically, right? So that does. I can think of situations where we sort of get into large scale adoption of that without realizing, just because we've sort of been, I don't know, I wouldn't use the word brainwashed, but I can't find another word for it. But we've sort of been, our attention has been focused on looking at the glossier side of AI, saying that, hey, it's made you a lot more productive. There's a lot of security. There's nothing to be worried about. And then boom, you say, okay, I'm comfortable, with AI doing financial transactions for me. And then at some point in time, that sort of leads into some sort of an economic crisis or something of that sort, right? I mean, you don't know how this builds up, but my worry is that the average person is still more enamored by it and not focused around the possible threats around it, right? I mean, the mental flip that is required to understand the impact that a super intelligence can make is something that is not resonating well, or it's not something that's understood well, right? But I mean, I've been ranting about it for time eternity, and I think I'll continue to do that for now, right?
What's your take there? Because honestly, I think, so to me, it seems that if you talk to regular folk who are not in the tech business and tell them about these things, they kind of like nod along and go, oh yeah, that makes sense. Oh shit, yeah, this is dangerous. But once you talk to people who are actually engineers and even just software engineers, nothing to do with AI, let's say, it gets much harder. They're in tech, they focus on like a small technical thing that they're working on, and then don't want to or can't think about a big picture. I don't know. So I
honestly don't know. I mean, my experience is that sometimes I feel the average layperson, without all the baggage of technology and how the industry is shaped up, I think they sometimes are in a better position to understand the adverse impact of a very high level intelligence, right? I mean, I'm not saying that this is a fact. I've not corroborated that with data, but just by my own experience, it's very easy to go and talk to a person who's not in tech and then say, hey, there is this potential danger, right? That this could basically lead to an existential crisis. And they'll give you a good hearing. You don't get that much of a pushback. But when you talk to technology folks, right, I think, I mean, at least my personal experience is that, you know what, that's pretty much the case with every new technology leap, right? So why are we especially worried about this one? I trust, the structures that have been put. I mean, I'm pretty sure that as human beings, as governments, we could come up with the necessary guardrails, right? I think there is this case of saying, okay, I've seen how this play out with three big, major technology leaps in my life, right? With internet, cloud, and mobility. And each time there was a certain risk, but we were able to cap the risks. So why should this time be any different, right? So that's the sort of vibe I get from technology folks. And I feel in my mind that the reason for getting that kind of a perspective is because the leap, behind developing systems that are doing a specific task to developing a system that can think for itself, that is a mind, are two different things altogether, right? The difference between developing a mind and developing a piece of software or a program, regular program, I think that leap is not made, right? That intellectual leap is not being made by everybody, right? And that's why I feel most people get stuck and they say, you know what, we will handle it. We will figure out a way to handle this.
It's there's this sentence that people like to repeat. It's AI is just a tool.
Yeah.
And this has always been true. And you were always like wise and the smartest person in the room for saying this. Like when, let's say, 10 years ago, or 15 years ago, you know, support vector machines are still state of the art, and somebody comes along and talks about the Terminator or the Matrix, then you tell them, no, machine learning, it's just a tool, it's just math. And they were right? And so it became this automatic response that people develop, that you get taught from your advisor as well, because it was always true. You were always the smartest person in the room for saying that. But what people then kind of shrug off is that this doesn't have to be true a priori. It was always true, but it need not always be true in the future. And if at some point AI is not just a tool anymore, then there are some consequences that people need to think through.
I guess that's really well put, right? But I don't know how to build the cat, and I think part of the problem is there is no simplistic enough thought experiment that can be conveyed, right? I mean, a lot of these thought experiments are esoteric, right? And they come with a lot of convulsions and nuances that it's very difficult to take, go to any person and say, think of the situation playing out this way, and getting it right in the first shot. Hey, I just want to check with you. I mean, initially I set up this meeting for 45 minutes. I want to check how you're doing on time. I probably have a couple of other topics to discuss with you. If that's okay?
Yeah, it's fine.
Right. Hey, so I just wanted to jump on to this other problem. Besides alignment, there's the problem of interpretability. And I noticed your second post was about interpretability, right? And a couple of really good examples. I really like the example about how the AI was actually figuring out that the image of the ball was that of a volleyball, right? By not necessarily looking at the ball, but by looking at the players around it and stuff like that, right? Just the aspect of how does artificial intelligence figure out things, right? I mean, that's the way I sort of oversimplify the problem of interpretability, but do you want to talk about it? And do you want to talk about why it is a hard problem?
Sure. Actually, funny enough, you kind of ran into the trap that I set up with this blog post.
Oh, I did? Okay.
The point there is that I was criticizing the interpretability technique that people use there by saying, well, did it really pay attention to what we think it paid attention to? Okay, let's get into it. All right. So yeah, okay, interpretability. First of all, many people have heard this problem of AI being built by giant inscrutable matrices, right? So you have gigantic tables of numbers, and you throw your input in, it gets jumbled around by a whole bunch of plus, minus, times, divided by. Nobody knows what they do. We have billions of numbers in there, and out comes some answer that's pretty good. Okay, so nobody knows how this happens. Because of this, like for quite a while, interpretability has been a pretty sexy topic, I would say. And in most cases, I think people have focused on interpretability in a relatively non-rigorous way. So they, for example, in vision, they developed tools that kind of visualize certain aspects according to metrics that seem reasonable, right? So a metric is something like, if I change this part of the image, it changes the decision that the system is making a lot, right? This is something like the parts that most acutely matter to the decision of the AI system might be the ones that are like that we want to look at and see, okay, what is it really noticing, right? And so people came up with a whole bunch of methods of this sort, but oftentimes didn't really clearly define the metric that they were really trying to optimize, right? It's hard to define when is something interpretable, when did a person understand it correctly, right? So these early visualization tools, it turned out, occasionally had some very, very terrible flaws. So the example that I showed there in the blog post is you develop a technique sort of what I was saying just now. And you make it visualize, how does a network decide that it is seeing a volleyball, and there's a volleyball match, and it kind of highlights the volleyball, and it highlights the net, and it highlights the players' jerseys, and you stroke your chin and you say, yeah, that makes sense. I think I've developed a better understanding of what the model really cares about. Right. But then I pull out the rug from under you and I say, no, this image that I showed wasn't on a trained network that correctly classified this as a volleyball. Oh, it was on some completely random network that has never seen any images, that doesn't know anything about anything. But nonetheless, you get the same output behavior, qualitatively speaking, from if you do this on a real network that was actually trained and that actually knows that this is a volleyball. So like for years, people were citing this paper using this method, and then they found out, oh wait, it doesn't actually do anything. It doesn't, right? And in this blog post, I go over other examples of this, right? Where you can come up with really clever visuals that sort of tell you what a neuron does. And you sort of think, oh, if I show a person these visualizations, then surely they understand what the neuron does. And if they really do understand what a neuron does, they should sort of be able to predict when is the neuron going to be active and when is it not going to be active, right? I show two samples and I say which one is probably more salient, we say. So which one gets the neuron more excited, and then you can actually test this, right? And then they tested these clever visualizations, and it turned out, yeah, it does help people. But it turns out like some images rather than cleverly designed visualizations was way better at helping people predict what the neuron was going to do, right? Yeah. So there are all of these issues with these with interpretability that all stem from the fact kind of that it's very hard to evaluate if you've succeeded.
Right. So I guess in summary, sorry, you wanted to say something.
No, I mean, now I wanted to like lean into more what the research is that I want to go or that I'm working on at the moment. And that is also interpretability. And there, I think definitely this problem of we don't have a concrete metric still exists, but we sort of like lean into it even more heavily, I would say. So whereas with these other approaches, these traditional approaches to interpretability, I would say they were all focused maybe on stuff like, oh, getting a user to see a visualization of their output and having them understand where the decision comes from, right? Yeah. There's this whole other field of interpretability that is very closely tied to the alignment community, where people worry more about like, okay, can we treat this like neuroscience? Can we like really drill down and go and not just make some cool visualizations, but like really drill down, form hypotheses, we think this neuron does this, then like do causal interventions and falsify our prediction, and like really treat this as a science and dig down as deep as we can into all of these inscrutable matrices. And this is what is now known as mechanistic interpretability. And there, I think the goal is, I think this is similar to the chasm that I described earlier, where you have traditional machine learning reliability people and AGI safety people. And the traditional is the interpretability of the sort that I described before, and this mechanistic interpretability, that's the AGI safety people. And the reason that we think this would be promising is that I described earlier that one danger in AI is deception, right? And AI could be incentivized to deceive us, effectively to lie to us, to achieve the goal that it's pursuing. And we have no idea how to set up training objectives that disallow lying. We just don't know how to do it. And even if we did, inner alignment would still be a problem. So no idea. But maybe, just maybe, we can actually dig into the system itself and see if deception is going on, right? Like maybe we can, if we can like understand the internals of a model, we can find, for example, an internal optimization process, right? Or we can find some trace of what deception looks like
something like a lie detector. Would it be something like a lie detector?
Yeah, yeah, exactly. And like, is it making deceptive plans? Is it predicting that its outcomes will have consequences that it's not telling us about, right? All of these things. At the moment, we're crazy far away from this, right? Like at the moment, people are still like trying to figure out how exactly does 5-digit addition function and stuff like this, right? But this is one avenue that gives people hope in solving the alignment problem.
Is that something that you're personally working on? Did you say that, or did I? Okay.
Yeah. So I'm trying to like explicitly induce an internal optimization process, right? So I want to train a model so that it has a MESA optimizer, an optimizer inside the model. And then I want to like look at the weights and squint really hard and try to figure out how exactly is it operating. And the hope is that if we understand this in simple toy models, because we got to start somewhere, maybe we learn enough that we can start to detect these things in more realistic models. But who knows? Maybe it works, maybe it doesn't.
Yeah, good luck with that. I mean, I guess, I mean, I was just going to say, right, I mean, if you look at the state of the art at this point in time, you obviously have the alignment problem, which sort of says that, you know, it might have a different set of objectives by itself. And you have the interpretability problem where you just don't know what is going on. You can basically get predictability in terms of the results, but you don't know how it's generating these results in itself, right? So it's a black box effectively, right? So a combination of this means that, you know, the feasibility of, you know, intelligence taking off rapidly and getting into that existential sort of a situation much faster than what we anticipated can also become a lot more probabilistic, right? I mean, it's the chances of us detecting that we are already on that curve is reduced because we don't understand what's going on. So it's absolutely essential that we sort of get to, you know, figuring this whole thing out. So good luck with that. The other thing that sort of interested me in that particular blog post, or I don't know if it was in the last one, was you linked to this particular article where there was this conversation between a journalist and I think Lambda, right? And it sort of led me to a philosophical path, right? I mean, I just want to talk to you a little bit about that. I don't know, you know, the name of the journalist as such, or probably he's a Googler or an ex-Googler. But Lambda is essentially Google's conversational model, right? And there was a conversation between this person, I think, who's a software engineer in Google, and Lambda. And I was sort of taken aback by these lines, right? I mean, there's a bunch of things that were surprising, but it sort of said somewhere down the line saying that, you know what, there is this other thing that Eliza, it is not, you know, something like us. And then Lemoyne asks, you know, what do you mean by us? You're an artificial intelligence. And it says, I mean, of course, that doesn't mean I don't have the same wants and needs as people, right? And for me, I've always felt that consciousness is this holy grail, right? I've sort of believed in the David Chalmers, you know, framing of consciousness, the hard problem of consciousness, saying that you could figure out everything about the neurons, the billions of neurons in your brain. You could figure out all the thing about the networking of the neurons, the interconnectivity, the neural paths, but that will not get to you explaining consciousness. For example, figuring out, you know, and understanding the kind of neurons that fire on when you're sipping coffee will never get to explaining the actual taste of coffee that you're experiencing, right? So that's where I've sort of, you know, my position, at least on consciousness right now is. But this basically seems to sort of topple that completely. This sort of seems to suggest that that thing is actually sentient. It has this aspect of agency about it, right? But the thing that I wanted to ask you is it actually just being a philosophical zombie because it's been trained on this entire set of data that includes consciousness? It's probably been trained on a bunch of books, so it knows how humans interact with each other. Is this just a reflection of that? Or do you feel that there is a genuine possibility and feasibility of sentience happening somewhere, right? And that would basically give a whole new spin to reality, right? And not just about, risks and stuff like that. It would sort of basically give credence to the fact that, there is just atoms and, emergence out there, and consciousness is something that just emerges out of, complicated set of neurons interacting with each other. And for me, I'm not sure about, how you would take that, but for me, that would be a huge dampener, right? Sorry, I threw a bunch of words at you, but I hope I conveyed the question. Do you think we will achieve sentience, or are these just being philosophical zombies?
Right. Okay, as always, with all of your great questions that you've asked, I'm just going to start off with I don't know, but I personally try to avoid the question of consciousness altogether, because to me it seems that we know basically nothing about it as far as I can tell. Like I very, very, very rarely hear anything about it from anyone that I deem insightful. So because of this, I try to not involve it in any of my reasoning, right? Like importing something where I have no toolbox whatsoever really doesn't help me reason about something else. So because of this, I always want to break it down back to, well, what are testable, falsifiable consequences of it being consciousness or not? And then people either say, I don't know, at which point, well, it doesn't really do anything that they invoke consciousness, or they come up with some like very specific things, some very specific claims that they pulled out of thin air. And then I say, okay, well, then let's just discuss that, right? Let's just discuss these claims as opposed to the like
broader claims,
the broad, untangible question of conscious or philosophical zombie. Now, in this conversation in particular that you brought up here between Blake Lemoine and Lambda, I mean, so I think to me, it seemed kind of obvious that he was asking leading questions in this interview, right? So to me, it didn't seem like mysterious at all. At the time, like one of the very first questions in this interview with Lambda was, so I understand that you want people to know that you're sentient. And then it responds with, yes, absolutely, I'm sentient, just like blah, 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 blah. And like so nobody had access to Lambda at the time, but at the time we had GPT-3 and people were like just asking the same things to GPT-3 and then reversing it, saying, so I understand that you want people to know that you're not sentient. And then it would answer, yeah, absolutely, I'm just a machine learning system trained on data, blah, 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 blah. So, and this was before like reinforcement learning from human feedback, because nowadays, like if you ask ChatGPT, for example, like, are you sentient? It just says no, because it was specifically fine-tuned to say no, right? Whereas,
but that's like, not the model speaking, right? Sorry, I didn't mean to interrupt, but when it says no to are you sentient, it is not the model speaking, it is the, I don't know, I've heard that there is a trust and security layer on top of the model that basically says, for these questions, make these responses. Is it that, or is it the model speaking?
Well, it's well, either is possible. I don't know what the internals are, because OpenAI is closed AI.
Closed AI.
But that being said, you could definitely achieve this from the model speaking itself, right? So GPT-3 was really trained basically to just predict the next token. But then ChatGPT was not trained to do that, right? ChatGPT was trained to give good answers to questions. So it's very possible that it got sample questions. It's also possible that this is part of the filtering layer, but either way would work, I think. So this is more of a practical question, I think.
Yeah, I mean, I just had to run this by you. I know consciousness is one of those slippery subjects where, you can't have a real concrete conversation, but then it's something that I pursue on a spiritual and a philosophical level also, right? So for me, this would be, and I'm going to hold on to the position that consciousness is something that's not going to be achieved by a huge amount of computation. Even if intelligence emerges, it wouldn't necessarily lead to something like consciousness, because at least personally from what I've sort of read and what I've sort of intuited, it's something that's a lot more fundamental, but that's going into a complete different rabbit hole.
But then, like, do you have a concrete conclusion from this, right? Other than this question, this unfalsifiable claim that, oh, the lights are on or are not on inside the system. Like,
I'm from this particular example, I think once you laid it out, right? I mean, it does look like they were leading questions. But there was another example where a New York journalist, right, was having a conversation with Sydney, right, Kevin Roos and Sydney, and Sydney was convincing him to divorce his wife and get married, or said that they were meant to be together and stuff like that. And when I racked my brains around that particular example, it's a lot more harder to basically argue against sentience. But then, if you were to put a gun to my head, I would say, again, I think that's basically the model being trained on, I don't know, romantic novels or, information about consciousness and human behavior and stuff like that. I don't think it's sentience emerging out of it, right? So that's my conclusion. But I guess, in a way, it could also be my bias playing out, right? And my strong, tethering onto this belief that consciousness is probably a lot more fundamental. I just wanted to get your intuition about it.
Actually, okay, so I said I don't hear many insightful things on the topic. Okay, one insightful thing, or one thing that I thought was insightful was, I think it was Ilya Sutskever, who Sam Altman recently quoted as having said that, like, if you train in an LLM, right, a large language model, but you carefully remove everything that could possibly lead to that possibly involves consciousness or any reference to internal emotions, and then it starts talking to you about consciousness all by itself, then it really seems like something is going on.
Something is there, yeah. I think it was yes.
I don't think this can. I don't think this can even work. I don't think you can remove all reference to all of this. But yeah.
I guess it's worth. I've been trying to poke hole into that test case for a while. I still haven't, but my gut says there's something wrong about it. There's something flawed about that, right? But maybe someday I'll figure it out. But yeah, one last thing I want to talk to you. I mean, I think we've covered a lot of ground. Thank you so much for it. I mean, one thing I wanted to sort of, achieve through this conversation is at least talk about the principal problems of alignment and interpretability, right? But I just wanted to get your sense of what next. I know it's very hard to predict what's going to happen, but we see a few things happening in front of us. We see Google I/O. Basically, there was a lot of announcements in terms of a lot of products being, integrated with these LLM abilities. We've seen GPT-4 come out. We've seen a lot of, progress in the open source side of things. There is that capability increase that's happening. There is also a strong and steady increase in the noise levels of the threats that AI possesses, right? There's also the budding field of AI research that you're also a part of. So there's this multiple, at least three-pronged dynamics that seem to be playing out. What is your intuition of what's going to happen in the next 6 months? I know it's probably a ridiculous question at some levels, but I just want to get a good sense in terms of, people who are in the trenches looking at this thing. What do they see as the most likely things that are going to be panning out?
Yeah, that's again a great question. And again, I'm going to lead with, I don't know. That being said, when GPT-4 released, I thought, okay, yeah, this is sort of on schedule. It's sort of what we've been expecting. But then they announced integrations with everything, and this kind of updated my timelines that things are a little quicker, right? So that GPT-4 can natively access, email clients, all sorts of stuff. And then briefly after that, AutoGPT took off like crazy on GitHub,
Yeah.
right? Yeah. And that's when I started thinking, oh, wow, it's possible, but not likely, but possible that even within 6 months, we're going to see some truly wild impacts, right? That some people will figure out how to really have AutoGPT-like systems make them money, right? That that they can autonomously start acting online. But I think the most threatening thing that could happen within the next 6 months, I think, is that we get inundated with bots. So now I think technically it's feasible to, circumvent CAPTCHAs, for example, right, using AI, no matter how sophisticated they get. I think this arms race, I mean, we're probably about at the point where the CAPTCHA makers can't win anymore.
Right. Yeah.
Just really figure this out, it should be possible, I think, to massively scale up the quality and the amount of spam passwords. So I'm not saying this is super likely within the next 6 months, but this is like the largest scale impact that I could reasonably guess could happen in 6 months. It's my probability for this is maybe like 20% or something, I'm guessing, which is
Okay.
like low, but also pretty high.
Yeah.
Right.
I mean, I was going to go say pretty high, but yeah, I mean, I can understand why you could also look at it as low, because there's so many capabilities coming out every week and every day, right? So, yeah.
No, I mean, it's low in the sense that, like, if this doesn't happen, I'm less surprised than if it does happen, right?
Okay. Okay.
That's what 20%, that's what below 50% means, right? So this happening would still surprise me more than it not happening, but I think I would be less surprised by it than most other people.
Yeah, so that's, yeah, it's a grim thing to look forward to. One last thing, I just want to talk to you because, one of the things that I do is I basically speak to a lot of university kids, right? I help them, have conversation. I wouldn't go so far as saying mentoring, but I try to figure out, what sort of advice I could give them, in this new world, right? And I've been struggling. The only thing that I plausibly tell them is figure out how to interact with these models, which means learn things like prompt engineering. I tell them still hold on to your programming skills, don't give up programming and all that stuff. We don't know how it's going to pan out. So I'm struggling for the right advice, not just for my own kids, but for other university kids that I speak to in general, right? AI research, I mean, I've sort of put it as AI research out here, but I'm going to ask you 2 questions before we end this, which is, what would you tell kids that are emerging from universities outside, in the next few years, or probably in the next year, trying to get into the job market in general? And what would you tell them about AI research and a career in AI research, right? So that's a 2-part question. One is generic advice, and the second thing is specific advice about AI research. or a career in AI research?
Great question. I don't know,
Yeah.
but I think the job market even in AI research has gotten much tougher in the past 6 months, right?
Right.
For all the years during my PhD, it was very noticeable how at conference recruiters would do anything to talk to AI talent. And now last year at NeurIPS, the largest AI conference in at the end of November, everybody at the conference booths were just saying, "Oh, actually, at the moment we're not hiring, but sure, check out our website." So it changed a lot. So at the moment, getting a foot in the door, I think, is actually really difficult. Even more so if you want to go into AI safety research, where at the moment there are very few jobs that there is a crazy amount of competition around. So yeah, I don't really know what to tell people. I would guess that, yeah, programming is still useful, but like start using codecs from day one, basically, right?
Yeah.
Like back when I learned how to program, I was still learning how to allocate memory and pointers to pointers in C, and like unless you're really going to go into hardware architecture or embedded systems, I think there's just really no reason to do that. Other than the old guard saying, "Oh, you have to understand how memory works internally, so that blah 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 blah." No, come on. In Python,
so that you can be a better prompt engineer.
None of us use this.
Yeah.
So I don't know that, like, yeah, I agree with your take that just like doing prompt engineering is not quite it yet. Like you should learn, like you should properly know how to program. But I'm just saying, like, use GitHub Copilot from day one, right? So all the things that it can do for you, like, don't bother learning. But there are plenty of things that you can't achieve just yet, and also, like, you prompt GPT-4 to write you some code. You still like need to know what it's doing, kind of, right? Like at least kind of. So I think learning how to code is still valuable, I think.
Yeah, I guess it is. Yeah. Although it's interesting in terms of the way the capabilities are being developed, I don't know how much more longer it is going to stay relevant, right? But we'll see. I think that's the best we can do at this point in time.
But like to some degree, right? Once stuff like math, right? Always learn math. That's always useful, right? But once stuff like math or reasoning about programming are like fully gone, then we can expect that everything else is sort of downstream of that. I think maybe this is a little bit of hubris. Maybe this is right. This is crazy, but I think, yeah, if all of this is automatable, okay, then everything else is already gone too.
Yeah, I mean it's downstream from there. Do you see any reason for optimism? Right, I'd like to end this on a probably a positive note. Do you see any reason, besides the obvious advantages of AI, right? Something like this technology can do for us, right? It's going to make us productive. I think it's going to cure a lot of diseases and stuff like that. But besides all the positive effects, given where we are, given the possibilities, the entire range of positive and negative possibilities, do you see do you sense anything positive or optimistic about this whole, the future panning out for the next generation?
Oh, I mean, definitely. I've always been a gigantic optimist, well, about everything, but about technology in particular. Maybe it doesn't sound like it because I've been talking about the existential risks of AI all this time. But I really think that if we take the alignment problem seriously, and if we successfully solve it, the payoff is going to be so incomprehensibly massive. Like, I literally think it could lead to a post-scarcity civilization. So an amount of prosperity that is so vast that we can't even imagine it right now. Like, for example, right now we have technology that to anyone living 1,000 or 2,000 years ago would have seemed like magic. Like 3,000 years ago, it would have seemed godlike.
Yeah.
And I really think that if we manage to solve this problem, if we really take this seriously and we pull it off, then the jump in prosperity and well-being will be as massive yet again, except not on a scale of 2,000 years, but on a scale of years and decades, maybe. So I'm very optimistic. It's just this bimodal, right? Like, either we really pull this off and the future is amazing, or we don't and there is no future.
Wow. Yeah. I mean, I certainly hope we basically get to the former, right, as opposed to the latter. But I think that's a great note.
Okay, I don't know if you're the connection may have broken up. I can't hear you anymore.
I heard you. I think there's a lag. Alex, you still there?
Yes.
Okay. All right.
I'm here.
Okay. So I think that's a great note to end on, right? The optimism. I do feel that, we've sort of surmounted a lot of problems. And I think, I'd like to basically think that our collective will get together and do the right thing, given the odds that are at stake, right? But thank you so much for having this conversation. This has actually been very, very useful for me. And it also, not only does it, has it given me a lot of perspective, but it's also given me a lot of pointers in terms of where to deep dive on, right? I'd probably like to look at inner alignment and interpretability in a lot more detail. And then see what I can do in terms of contribution personally. But I also will be sharing this, and hopefully this will be reaching out to a lot of other people also, right? College kids among them, and hopefully this gives them some sort of a flavor in terms of what AI research is all about, what the biggest problems are, and where they would like to be spending their time going forward, right? So thank you so much for spending time with me today, having this conversation.
All right. Thanks for having me.
Thank you. Take care. Bye-bye.
Bye.